Welcome friends, welcome back to our channel Crystal Learning. So today we will learn a concept related to the subject, that is strength of materials and material science. Some of the times properties of the material like yield strength, tensile strength, failure strength, etc. are being taught in material science subject also, and sometimes it is taught in strength of material. So it can be studied in both subjects. So let's see the question. Question says, in UTM experiment of sample, a sample of length 100 mm was loaded in tension until failure. The failure load was given 40 kilonewton. Displacement measured using the crosshead motion at failure was 15 mm. The compliance of UTM is constant and is given 5 into 10 to the power minus 8 meter per newton. Then it is asking that strain at failure in the sample is. So it came in GATE 2019 morning session. So this is the reference taken, standard method for tensile strain and young modulus. So before solving, let's see some definition. Tensile strain we know F by A, failure load divided by area, meter square. Engineering strain, change in length upon original gauge length. Okay. Percentage elongation, it is defined as maximum amount of plastic strain or failure strain at a tensile sample before it fractures. Okay. So we have to calculate this value only. Percentage elongation, that is change in length at fracture divided by original length into 100. So this value we have to calculate here. Okay. So just revising. So here I have drawn very bad. My drawing is literally bad. So you can see your UTM machine. There is a part here that is known as crosshead. So when you apply load, this part moves. Okay, it is a movable part. It is a fixed part, and there are some jaws or gripper system that grips your sample. This is your sample. Okay. So what happens? The crosshead moving. Suppose that it has moved 4 meter. So sample will stretch 4 meter. Then only it can move 4 meter. Okay. So this is the reading which we note down and we calculate the stress strain curve. But sometimes for accurate measurement we use extensiometer. Extensiometer for very accurate measurement. So extensiometer is put in the range of this sample and it is directly measuring the displacement of this sample. So that gives accurate measurement. But in most of the labs in engineering, we don't use this extensiometer. So we get a rough value of this stress strain curve. So for accurate measurement, they give this compliance value of this machine. Then if you don't have extensiometer, then also you can get these values accurately. So for that part, compliance value comes. Okay. So let's see few more definitions. So what is stiffness? Stiffness of a body is a measure of resistance offered by an elastic body to deformation in response to an applied force. When we apply a force on elastic body, it will try to resist. That is known as stiffness. How stiff a body is? So that value is calculated by K equal to F by delta. F is force and delta is the displacement produced by that force. Okay. It can be thought of a spring that F equal to K delta, K, and unit is Newton per meter. What is compliance? Compliance is inverse of stiffness. Is also known as flexibility or compliance. Typically, its unit will be meter per Newton. Opposite of that is K. So it can be said the more flexible an object, less stiff. Okay. So the value of compliance is more, then the body will be less stiff because it is inversely proportional. Now the concept comes equivalent spring. When springs are attached in parallel, K equivalent is given by K1 plus K2. And when it is attached in series, 1 upon K equivalent equal to. This formula we know. Similarly, equivalent compliance will be K equivalent will be 1 upon C eq. From this formula I know. So this formula change 1 upon C1 plus 1 upon C2. And C equivalent will become C1 plus C2 in series. So if we see gripper system is there, then sample is there. So it is attached in series. Okay. So we will apply this series formula. Let's see the formula. So in UTM, cross head consists of gripper system and metal sample connected in series, and both gripper and metal sample are elastic bodies. So the displacement or compliance of crosshead will be using this formula. That will be C of crosshead equal to C of sample plus C of gripper system. So crosshead value is given by delta L by F, because it is opposite of stiffness. Stiffness is given by F by delta. Then compliance will be given delta by F, or change in length. So change in total length by crosshead movement divided by failure load equal to delta L of sample plus failure load, or plus CS, that is compliance directly, because here the value is given gripper system compliance. Multiplying with F on both sides, delta L equal to small delta L plus CS and F. This is the main formula we will be needing to solve this problem. So this is the derivation. Okay. So now let's put the values. So small delta L we have to calculate. So that will become capital delta L minus CS F. So capital delta is given change in crosshead displacement, that is 15 mm or 0.015 meter. Small delta L we don't know. Capital delta is given 100 mm or zero point 0.1 meter, assumed to be gauge length. It has to be gauge length. Okay. CS value is given, and failure load 40 kN or 14 to 10 to the power 3 meter. So strain at failure we have to calculate epsilon F is equal to percentage elongation delta LF upon original length into 100. The small delta L at failure will be delta L minus CSF. 0.015 minus 5 into 10 to the power minus 8 into 40 into 10 to the power 3. Always pay attention towards the unit. So it will come 0.013 meter divided by 0.1 original length into 100. It will come 13%. So as predicted, because it is coming 13%. If you don't know what is compliance and you have to give a blind guess, so you can simply in the starting you know that change in length will be in the sample will be 15 mm at max divided by original length 100 mm into 100. So it will be less than 15%, not more. You can't give 16 or 17%. So if you can write then 14% or 13%, blind guess, because some of the institute gave 2% when that gate answer key was not there. So this is just a blunder. So for blind guessing, you have to know the concept also. We know that it will be less than 15%. I hope you enjoyed this lecture, and the concept of compliance you got to know, because in very good institute like in IITs or NITs they might be teaching this. So there they use this concept of compliance. Otherwise we just note down the crosshead displacement and we calculate the stress strain curve and all that. So we meet in the next lecture with the next question. Till then, have a nice day.